Hi, this is Mr. McGovern, and the sixth and last video in the electric field series where I look at an NCEA problem, and this is from 2016. So it says an X-ray machine, it's got a heating element, it releases electrons from the negatively charged plate, and those electrons are accelerated by an electric field towards an anode. The anode and cathode are connected by a high voltage source of 20,000 volts, and the distance between them is 0.05 meters. Okay, we're given this a charge of electron and the mass of electron as well. So the first question is asking for you to calculate the electric field strength between the plates and state its direction. So the electric field is given by volts divided by distance, and so there's 20,000 divided by 0.05, and that number is 400,000 volts per meter. The electric field strength direction is which way a positive test charge would go if released. So if I dropped a positive in there, it would go to the left. So even though I haven't written left, because I've forgotten this video, that is the answer. I need to say to the left. What type of energy would an electron have at the cathode, and what would happen to that energy as the electron moves towards the anode? So it starts on the left-hand side, and an electron is going to be accelerated towards that positive one. It's going to be pushed away from the negative plate and towards the positive. So it's going to start with some potential energy in the electric field, and it's going to end up with kinetic energy. So I just got to write that in words. The electron has electrical potential energy at the negative plate, and by the time it gets to the positive plate, that energy has been converted into kinetic energy. So it's a merit for both of those points. Calculate the speed of the electron as it reaches the anode. So I'm doing the same thing, but I'm just writing as an equation. Electric turns into kinetic. Electric energy is to kinetic energy. I have a formula for my electric energy, which is equal to EQD. Now remember, the E on the left-hand side is what I call electric energy, which is the triangle E, and the E on the right-hand side is electric field strength. So you make sure you don't get those two mixed up. And I got a formula for kinetic energy, half mv squared. I'm confident enough that instead of just working out one at a time, I can just equate those and rearrange to find velocity. So I'm going to divide times both sides by 2. I'm going to divide both sides by m. Now I've got v squared, so I'm going to square root, and then just put my values in. So 2, the electric field strength I found in the first question, which is 400,000. The charge of the electron is 1.6 by 10 to the minus 19. The distance was 0.05 divided by the mass, 9.11 by 10 to the minus 31. Find that on my calculator gives me 8.4 by 10 to the 7. Now that's very fast, but electrons are very light, so they're easy to accelerate to quite high speeds. So that was a merit as well. Last one says, Millikan oil drop experiment used 2 oppositely charged plates to keep an oil drop from falling. A modified form of this experiment also keeps an oil drop stationary. The diagram below shows part of the equipment. So discuss how it's possible to make the oil drop stationary between the plates, and your answer, you should. Identify the forces acting on the oil drop, describe how the forces can combine to cause the oil drop to be stationary, and explain. There's a key word there, explain what type of charge the oil drop must have to remain stationary. Okay, so I'm going to identify the forces with a force diagram. If it's a stationary oil drop, there's a net force of 0, so there must be balanced forces. Gravity is obviously the force pulling down, so there must be something pulling up, and that is an electric force. So I'm just going to write that as a sentence because that's what I need to do. The forces, electric and gravitational, must be equal and opposite, and this would give them a net force of 0 and allow the drop to remain stationary. The last one's saying explain what type of charge. So I can't just say positive or negative because I need to give a reason. Explain means give a reason. So the charge must be negative, and this is because it's repelled away from that negative plate at the bottom and attracted towards the positive plate at the top. That one's an excellence, and that's the whole question from 2016.